As a continuation on explaining the kinetics of enzyme catalyzed reaction, this lecture we're looking at the transformation of Wolf-Hane's equation to Eadie-Hoffstee's equation. So this is Wolf-Hane's equation. How do you transform it to Eadie-Hoffstee's equation? The first step is to multiply through this equation by initial velocity multiplied by maximum velocity. So this is this times V over max, this times V over max, and this times V over max. If you cancel out V over V over, we have this left. We cancel V max, second we have this, and then we cancel V max, we have this. At this point, the next step thing you should do, divide through the equation again by substrate concentration. So this divided by substrate concentration, this divided by substrate concentration, and this divided by substrate concentration. By the time you cancel out the thing, entities that are common in numerator and denominator, we're going to have this V max is left here equal to VO, which is left here, plus the whole of this VO Km over substrate concentration. And then the last step to get your Eadie-Hoffstee's equation is to make VO the subject of the formula. So this has to move over to the other side. So we now have VO equal to V max minus, this becomes minus as it moves over to join this, minus VO Km divided by substrate concentration. And then we'll write it this way, last step, to show what to plot on the x-axis, because we'll be plotting VO over substrate concentration. So we have Km times this, so this and this are the same. And then looking at this equation, we know if we're plotting this against this, then we know that the Km will be the slope. And you can see it's a negative slope. That is why the graph is looking this way, the plot is looking this way, because the slope has to be a negative slope, which represents minus Km. And then the intercept on the y-axis is going to be what is left there, which is the V max. So you can see that the Eadie-Hoffstee's plot, the same as the Wolf-Hane's, they have just one reciprocal, which is this one in this case. One reciprocal, while the other one is a whole number. So it's almost the same, except the fact that this graph gives you direct value for Km and Vmax, unlike Wolf-Hane's equation. That's the reason they had to advance this equation to this equation. So the best in all of this is the Eadie-Hoffstee, because at a glance it gives you the value of Vmax and the value of Km. And then this intercept on the x-axis gives you a direct division of Vmax and Km. So just like the other graph, which is the Wolf-Hane's plot, this plot also does not compress data at high substrate concentration, because the graph contains only one reciprocal, which is for this at the x-axis. I trust that we've done justice to this transformation and this aspect of enzyme kinetics. Do well to like what we do, share, comment, drop your questions, support us, and follow us on YouTube for more exciting, simplified, easy to understand video tutorials on biochemistry. Until I see you again, thank you very much. It's Dr. Juliet, and bye-bye for now.